Okay, hello, welcome to one final Mr. Hendry Does Chemistry, and this time it's molar gas volumes as requested in today's lesson. A reminder before we start that 1 mole of any gas at room temperature, about 20 degrees C, and atmospheric pressure occupies 24 decimeters cubed as a volume, and we're going to use that fact to work out the first few of these questions. As we're asked first to calculate the volume of 2.5 moles of hydrogen. To do that, we're going to do 2.5 times by 24, which is our volume, of the molar volume of gas, which gives an answer of 60 decimeters cubed. For 0.01 moles of tetrafluoroethane, which is a gas as well, we're going to do 0.01 times 24 to get an answer of 0.24 decimeters cubed. And there is 2 further questions that I've attached to this for that part. We're then going to calculate the moles given the volume, and to do that we're going to do mole equals vol over 24. So number of moles is 0.96 divided by 24, which is going to be 0.04 moles. And for this one with water vapour 1440 decimeters cubed, we're going to do 1440 divided by 24 to give us 60 moles of water vapour. Now we can be asked a kind of further step for these questions, and that's normally kind of similar to our reacting masses, where we're given a mass of something in an equation and we need to work out a volume of gas using the fact that 1 mole of gas is equal to 24 decimeters cubed at room temperature and pressure. So question I here says what volume of gas is needed to obtain 2.54 grams of copper. Well, if we have the mass of copper is 2.54 grams, our MR of copper is going to be 63.5, no units, remember, which gives our number of moles as 0.04 mole. Our ratio from copper to hydrogen, because that's what we're asked about in the question, is 1 to 1. 1 hydrogen will produce 1 mole of hydrogen will produce 1 mole of copper. That means that in this question, 0.04 moles of copper is going to require 0.04 moles of hydrogen. For us then to work out what is the volume of that, we're going to do 0.04 times by 24, which gives us an answer of 0.96 decimeter cubed. We could also be asked to do this like the question below here. What mass of magnesium carbonate reacts to form 6 decimeter cubed of CO2? I'm not going to show you fully how to do that, but we're going to need to think about that in the same way. We're first going to need to use 24 decimeter cube per mole to work out the number of moles of CO2, and then we can work backwards from there to work out the total mass of magnesium carbonate that's required. This is usually a 3 to 4 mark question in your GCSE paper. As I say, I will put a few of these up. If you want me to send me any answers, please do so, and please come find me, send me any questions on Teams before paper 1 on Friday.